So today I am going to discuss with you the most important topic in physical chemistry that has been asked in CSIR NET or GATE, whatever the exam may be. So these are the points that you can't miss before going to exam. So there are lots of chapter and there are several books. It's difficult to shortlisted the book which I have to read, which topic I have to read. That's why this video to help you with the subject and topics and the question that have been asked. So the first major important point is the spectroscopy. Spectroscopy constitute minimum 12 to 14 marks in each and every year, and you will definitely get question, simple basic question from this topic, and it's inevitable. For example, if you take last 4 years, I have some calculation here from December 17 to December 18 in each year, 2 exams. So that's why there are four consecutive year with an average of here 14 marks around, here also 12 marks, 14 and also around 14. So consecutively 4 year they have asked around average 12 to 14 question every year, so that you can't miss this point. So basically for this topic to cover, you have to go through the basic book manual. This book is little bit tough for some of the student, but it's very important for exam point of view and NET. So the topic you have to understand, go through are rotational spectroscopy, vibrational spectroscopy, Raman, as well as ESR and NMR. So these are the 5 most important topics from spectroscopy generally asked in the CSIR. And what kind of question they ask from this kind of topic? Basically they will give some molecules, for example methane, benzene. They will ask they are symmetric top, asymmetric top. They can give you spectra, what are the selection rule, symmetric top, what are the selection rule, it is allowed or not. So this kind of question generally asked from rotational, vibrational and Raman spectra. So these are the questions that have been asked. As well as with this kind of question, they may also ask some numericals basically on the energy gap, the transition which are involved in rotational, vibrational, Raman. So they also asked. For example, ESR in NMR. So what is the delta nu? You have to give in some B0 value. They can ask Larmor frequency. One more thing that is important from NMR is the pattern, how it will give the peak, what is the ratio, and ESR also, and Draco's rule. These are the important part from ESR and NMR. How it will split. For example, they can give you any active nuclei, and there are 4 or 5 active nuclei with each other. How will it split? What will be the intensity ratio? These are the basically point that covers in CSIR. So for ESR and NMR you can read Atkins as well as Banal. So these are the topic you have to understand. Let me come into the one point that is I missed here, Mossberg spectroscopy. Mossberg is also favorite topic from CSIR question. There are several questions have been asked in from Mossberg also. And quadruple splitting, how they split in presence of active nuclei, and hyperfine splitting in ESR. These are the important topic. Now let's come to the second point, that is quantum chemistry. So quantum chemistry is the I would like to say the first most major important topic. You just can't miss. If you see the previous 4-year question, minimum 20 marks is inevitable in every year. So 20 marks, you can mark my word, 20 marks. 20 marks means 5 4 marks question, or it may divide into 2 marks also. So minimum 20 marks you will get definitely in CSIR. So to cover this quantum chemistry, what you understand is the, let me, simple basic fundamental, starting from particle in one-dimensional box. What are the energy? How the one-dimensional box, 2D box and 3D box. For example, they may give you energy of a 3D box and they can ask you to calculate the degeneracy, or as well as they can give you some kind of transition and they can ask you for lambda, what will be the value of the lambda. There are several important questions from this topic, and if you see the last 10 or whatever you hear, you will definitely get question from particle in box. So it's the most important topic. Coming to the second point, commutator. Is the second most important topic. Commutator, generally they ask which is Hermitian or not, and what are the, for example, px, energy, how these operators related. They may ask also, for example, they will give like this systemic space, what will be the value of this commutator. And then they may ask also, they will ask generally, everywhere there will be questions, some from perturbation theory, as well as Hückel molecular orbital theory, the other thing is the variational theorem. So basically there could be several kind of exam question, but from perturbation, variational theorem, there are both conceptual question have been asked in CSIR. For example, they can give you 4 options which will be incorrect, which are correct. They can ask this kind of question, as well as numerical calculation they can also give. But for this case and as well as this case, whatever if overall, as an overall quantum chemistry, for quantum chemistry, Macquarie is the best book you can follow. Whereas so basically these are the important point: particle in box, 1D, 2D, 3D, commutator, Hermitian, eigenvalue problem. They will give some function with the operator. They will ask what will be the eigenvalue, as well as perturbation, Hückel and variational theorem are the important part. Sorry.
Wait a minute.
Okay. So one more thing that I would like to say is that this type of question has been asked in CSIR. That's why I am saying. Basically, they will give some hybridized orbital, sp2, sp3, or this kind of orbital, and they will ask you what is the they will give the coefficient and what is the percentage of character of each orbital. That's the question they have asked in CSIR or NET. So and then Hamiltonian, how is the Hamiltonian, Hermitian operator, operator's property, and these are the questions that is asked. Now let's come to the third most important topic, and it's pretty trivial, and you have already read this paper in BSc. So that's the topic is that thermodynamics. So thermodynamics is, you have reading from class 12, so it's very known to you, but it's equally important as well as in NET. So thermodynamics covers a large number of part in the CSIR. Let me give you some calculation here. Basically, December 17, there are 10 marks question from thermodynamics. June 17 as well as 10 marks question. Here also 10 marks question, and December 18 also 10 mark question. So as overall you can say 10 marks is inevitable in thermodynamics. So what are the topic in thermodynamics you have to go through? Basically thermodynamics, the most important part is the Maxwell's relations. Okay, Maxwell relations. You will be given 4 or 5 options, say, and they will ask you which is the correct option. For example, del T, del V with a relation with some other parameter. So they will give 4 options which will be the correct one. And we have already some videos how to predict the correct options. Okay. These are the most trivial questions that generally appear in the CSIR. And then the second point is the entropy change. This topic is equally important for NET and as well as GATE. So there are lots of several of process in thermodynamics: isothermal, adiabatic. And each involves separate equation, and you have to just they will give some basic numerical. They will give change the volume in pressure, and they will ask what is the delta S change, as well as in some phase transition they will what is the delta S. So this kind of question is very common in CSIR. The third point is the heat capacity and Troughton's rule. Along this four part, that is Maxwell relation, entropy change, heat capacity, Troughton's rule, they may ask you also the question kind of which will give us the spontaneity criteria, change of what is the work, and delta G, how it is gives Helmholtz equation. These are the important points you have to go through for thermodynamics. Coming to the point equilibrium, I am considering with this category, there are three concepts you have to understand. That is Le principle. This thing you have been reading from also class 12, but it's important from in CSIR point of view. Le principle, and they will give different criteria. For example, Born-Haber process, nitrogen, hydrogen, ammonia. They will give four conditions which is favorable to give the ammonia. I am just taking in one example. There could be lots of examples. What will be the effect of inert gases, and the relation between Kp, Kc, and involving numerical with this point, as well as some problems with partial pressure, and they will give you some reaction. They will ask you calculate the what will be the Kp, Kc from the data given. So I would like to say one point that in CSIR, the question based on numerical are you can say trivial. You have to just follow the equation. Whatever I am going to discuss here, one thing you can do common is that you can make a list of all the formulas. And if generally what happens that based on these formulas they ask question. You have to just follow the formula with proper unit. You will get the correct answer for the numerical part. So that was all about from thermodynamics part. Let me come into the fourth option, which is important, electrochemistry. So electrochemistry, there are lot of questions from electrochemistry as well as with the other part. So I am not going to discuss a full number distribution, but it generally involves around 12 marks or 10 to 12, you can say. 10 to 12 marks from electrochemistry. Basically my point of interest also here in electrochemistry. I like the chapter very much. So electrochemistry involves the basic fundamental equation, Nernst equation. From this Nernst equation, different kinds of cell, they may give you cell. They will ask you what will be the delta G value, E0 value, and what will be the K equilibrium, how they are related. Third point is that how the delta G, delta H, delta S, these are involved, and how you can calculate them. Basically some simple numerical. So again I am going to say with you that you just follow the formulas, and from that you can easily calculate the K equilibrium, delta G, delta H, and Nernst equation. So there are some other points I would like to say here. So they will give along with Nernst equation, oxidation reduction potential. The important point to solve the question from electrochemistry with the sign convention, you can't miss what will be the E0 reduction potential, oxidation potential, and how to apply, if it is left hand side, right hand side. These are the important points. You just go through them. The one more thing important, Latimer diagram, not only from CSIR, it's also for equally important as well as JAM and GATE. There are several examples from JAM and GATE. There are from Latimer diagram. They will give some different oxidation state. one of them E0 value will be given, they will ask to calculate the other E0 value. And then from this electrochemistry part, though not directly involved, I would like to say that Cold-Rush law and BY-Huckel theory. BY-Huckel theory, activity coefficient, one of the most important topic. So activity coefficient, there are lots of questions upon activity coefficient. Now, you already know the equation that minus log of gamma plus minus, that equation is very important, from which question has been asked. Along with this part, you have to also cover some point from conductance. Some basic formulas of conductance, conductivity, equivalent conductance, and in lambda 0 molar conductivity, how the units are related. And for example, say they will given acid, how they are dissociated, they will ask from alpha, K value. These are the typical problems that are asked in every year in CSIR. Now let's take the question from kinetics. Kinetics is one of the favorite question from CSIR. So generally there are a number of difference from 8 to 10 to 16. Maximum 16 can be asked also. So they may ask different kinds of problem from kinetics. So basically for kinetics, what you have to follow, several kinds of order of reaction, from starting from 0 order, first order, second order. You just follow the equations, write down the equation, every order, as well as with these formulas, draw the plot with y-axis, x-axis of different concentration, time, as well as how they are related. Just follow the equations of every rate equation and the corresponding plot. This is the one of the most important part. And the second part is that there are different kind of reaction. For example, parallel reaction, consecutive reaction. This is typically too much important. Parallel reaction and consecutive reaction, these are very much important. Consecutive reaction, what is the Tmax value, Bmax, you can calculate. That's the question they have asked also. Another point from kinetics is the Arrhenius equation and temperature dependent, as well as transition state theory. So these are the part that you have to follow for kinetics. The one more part is that enzyme catalysis. And if you see the last of past few year question, enzyme catalysis, from enzyme catalysis, for example, Michaelis-Menten catalyst, then Km value calculation, Bmax calculation. These are the based on simple numerical calculation. So you will definitely find one or two questions from enzyme catalyst, rate equation, integrated rate equation, from plot, transition state, consecutive reaction, parallel reaction. It's just enough for CSIR point of view. You will definitely get question from here. Now let's come into the point little bit hurry. In group theory. In group theory, there are some little bit in odd. Sometimes they ask question too many marks. Sometimes they just don't give question from group theory. But you can't neglect this part, because it involves some question, basically simple plot, graph, not graph, table. So sorry, not group part, group theory. So from group theory, what you have to follow, one thing is common, orthogonality, great orthogonality rule. For example, generally what type of question they asked is they give a table with some unfilled option. They will ask what will be the filled options here. So they will give 4 options. So group theory, this kind of question is very typical and trivial. They always ask. One thing is that vibrational, from vibrational spectroscopy, they will ask which, say for example T2 or A2, which kind of vibration, this is allowed symmetry, which vibration is allowed Raman active or vibrationally active, they will ask. For example, they will give you some molecule and the corresponding table, they will ask which will be active or not. Another point is that they will ask also, give some molecule and they will ask you to determine the point group of that system. So for group theory or point group determination, you just follow Hui and Mislater. There are plenty of examples to do. You just follow them, it will be sufficient. And one part I would like to say, group theory, you just go some basics. For example, if you have given some basis function and how they transform or change if I operate the symmetry operation. These are very important. And then for group theory, it's enough. You can get every question from this topic also. Now coming to the one of the most important part and quite easy also is the solid state, and you will definitely get a number of questions from solid state. The question involved from the packing fraction, then density, they ask density, and third point is Bragg's law. So packing fraction in 2017 as well as 2018 December, there are a lot consecutive question from packing fraction. They will give FCC lattice or BCC lattice. They will ask what is the packing fraction, and they will give option like this, pi by root 6 and pi by root 2, like that kind of thing. They may also ask you for density and then Bragg's law and then interspace, how much distance. These are the trivia question that has been asked from solid state. One more thing that is not asked previously, but maybe they may ask, is the systematic absence. Which kind of, for example, they can say this is FCC lattice, which transition, which will systematic absence, which plane will be observed or not. They will ask from this also. And basically this is enough for solid state. What is left? Then coming to the next point, I would like to say there are 4 or 5 questions. I will just write it in a single way. Polymer chemistry, absorption and surface tension. So I am writing in this simple polymer. You have to just follow some numericals. For example, weight average calculation, viscosity, and these are the molecular weight average. So MW, Mn, polydispersity index. These are the questions that has been asked from polymer chemistry. Whereas in absorption, you have to follow Langmuir equation. One particular topic which is of interest is that they will give a system of An which will give dissociative absorption. Say Na, An dissociate to give Na, and what will be the Langmuir equation? It's asked already. So this kind of question is very much a favorite for CSIR. And then coming to the point of surface tension, delta P, excess pressure, and one point I missed, that along with surface tension, some concept of micelle and the other things also important. So, and the topic that I am going to discuss with you is it's most important, but I mentioning it at the last, is that statistical thermodynamics. Statistical. From statistical, what you have to follow, again, some basic equations. What are the degeneracies? How, for example, they will give 2 molecules, 3 degenerate state and energy. How many ways you can distribute them? What are the energy? Then Boltzmann equation. These are the important point from a statistical point of view. Again, there are some also fraction of molecule probability, partition function is the main point. Partition function, degeneracy, how many ways you can distribute some molecules in a given energy state. So these are the question comes from statistical thermodynamics. Last but not in the least, I would like to mention the one point is that from photochemistry, you can say photochemistry is the Beer-Lambert's law is the important, and they have asked some basic question from also depending on based on Beer-Lambert's law. So I have discussed, I didn't miss anything. You have to, there are everything which can come from physical chemistry, everything is there. So I think it will be very helpful to you, and stay with us, subscribe and like. Thank you for watching.